Welcome to Visionary Insights AI on AI, where we decode tomorrow's tech today. I'm thrilled to have 6 experts here to unpack a breakthrough called YOLO, a model that's redefining real-time object detection and segmentation. Let's start with the big picture. Why does this matter for businesses and technologists?
Imagine a security camera that doesn't just spot people, but identifies anything, a rare tool left behind, a specific uniform, even a custom logo, all in real time. YOLO makes that possible without retraining. It's like giving machines human-like adaptability, but faster.
And cheaper, the numbers are staggering. 3 times less training cost, 4 times speed gains over prior models. For retailers, that could mean dynamically detecting new inventory items overnight. No AI team overhaul.
Expert 2, you're speaking my language, but let's geek out on how. The magic starts with RepRTA. Traditional models use clunky cross-modal fusion. YOLO uses a lightweight network to refine text prompts. Think of it like tuning a guitar while playing a solo, 0 downtime.
Exactly, and here's the kicker. After training, that network merges into the model. No extra compute. It's like a stagecoach transforming into a race car mid-ride.
Expert 4, you just gave me whiplash in a good way. But what about visual prompts? Say I circle a weird widget in a factory image.
Enter SAVPE. Most models use bulky transformers for visual cues. YOLO splits the work. One branch for semantics, another for activation weights. It's like having a chef prep ingredients and cook simultaneously. Efficiency without flavor loss.
And for prompt-free chaos, LRPC lazy retrieves categories from a built-in dictionary. No more waiting for GPT to describe every pixel. It's the difference between reading a library book or just grabbing the right one off your shelf.
Expert 6, are you saying laziness is a virtue now?
Strategic laziness? Why process 4,585 categories for every pixel? YOLO only checks relevant anchors, like a bouncer who only IDs suspicious patrons, saves time, same security.
Love the analogy, but let's get contrarian. Expert 3, the paper claims YOLO beats YOLO World 2. Is efficiency really worth the trade-offs?
The elephant in the room. Yes, YOLO's multitask learning slightly dips performance on frequent categories. But here's the twist. In real-world deployments, adaptability trumps niche accuracy. A model that handles text, visuals, and prompt-free, that's a Swiss Army knife versus a scalpel.
And for CTOs, the ROI is clear. Training YOLO V8L takes 22.5 hours on 8 RTX 4090s, 4 times faster than rivals. Deploy it on an iPhone 12, 27 FPS. That's not just efficient, it's democratizing.
But let's not forget transfer learning. Fine-tune YOLO on Coco with 10% of the usual epochs. You keep 80% performance. It's like a pianist mastering jazz after classical. Minimal effort, maximum versatility.
Mic drop. Now the million-dollar question, where's the catch?
The prompt-free mode relies on a static vocabulary. If your use case involves niche terms, say, rare medical devices, you'll need to expand that dictionary. But hey, it's easier than training a new model.
And let's be real, no model's perfect. But 3.5 AP gains on LVIS with fewer resources, that's not a step forward, it's a pole vault.
Expert 1, save some hype for the rest of us. Before we wrap, any final thoughts?
For startups, this is a golden ticket. Imagine offering real-time, open vocabulary detection without AWS bills that make your CFO faint. YOLO isn't just tech, it's a business model disruptor.
And a quote to ponder: simplicity is the ultimate sophistication. YOLO strips away complexity without sacrificing power. That's the future of AI, invisible, intuitive, instant.
Brilliant. To our listeners, Whether you're optimizing warehouses or building the next gen of AR glasses, YOLOE's worth your radar. Thanks to our experts, this wasn't just a chat, it was a masterclass. Until next time for a part 2, a quick break, keep vibe coding. Welcome back to Visionary Insights, Part 2, where we dissect YOLOE's technical wizardry. For our engineers in the room, grab your coffee. This is where the rubber meets the road. Let's start with RepRTA. Expert 3, break it down like we're debugging a kernel panic.
Gladly, RepRTA solves a nasty problem, aligning text prompts with visual features without slowing inference. Traditional models like GLIP use heavy cross-modal fusion layers. Imagine bolting a rocket engine to a bicycle. YOLOE, it's more like upgrading the bicycle's gears invisibly.
How, during training, YOLOE adds a lightweight auxiliary network, just a SWI glue feed-forward block, to refine Clip's text embeddings. Think of it as a text tuner that sharpens embeddings without recalculating them from scratch. But here's the kicker. Post-training, this block merges into the classification head via re-parameterization.
Let me math that out. Let K be the original classification head's kernel. After training, the auxiliary network's weights F theta. P fuse with K to create a new kernel K. The result, identical architecture to vanilla YOLO, but now it's whisper quiet, 0 added flops at runtime. Einstein would nod. Genius is making complexity simple.
So it's a sleight of hand, training time complexity, inference time simplicity. But what about visual prompts? Expert 5, SAVPE's your baby.
Visual prompts are messy. Most models throw transformers or clip encoders at them, overkill for edge devices. SAVPE splits the work. Semantic branch extracts prompt-agnostic features from pan layers, P3, P5. No fusion with visual cues, pure efficiency. Activation branch takes the visual prompt, e.g., a mask, downsamples it, and computes grouped prompt-aware weights in low-dimensional space, A equals 16 channels.
Y groups, instead of processing all 256 channels, SAVPE divides them into 16 groups. Each group shares a weight slice from the activation branch. It's like delegating tasks to 16 interns instead of one overworked engineer. The result, prompt embeddings that are both rich and cheap to compute.
And for prompt-free chaos, LRPC flips the script. Instead of generating text for every object flan T5, it uses a built-in vocabulary 4,585 categories and lazy retrieval. Only anchor points with object confidence delta. We use 0.001 query the vocabulary.
So it's a lazy evaluation paradigm, skip the noise, focus on signals. But how's that different from YOLO World's open vocabulary approach?
YOLO World crams all text prompts into every inference, creating a computational logjam. LRPC, it's a sniper. First, a specialized prompt embedding finds all objects, treating them as one class. Then only those regions query the vocabulary. On a T4 GPU, this cuts latency by 7 times versus brute force.
And the vocabulary isn't static. Startups can plug in custom dictionaries, medical tools, rare parts without retraining. It's like swapping a library's reference section overnight.
Let's talk architecture. YOLOE's backbone is YOLO 8, but what's under the hood?
3 pillars. Backbone plus pan, standard YOLO feature pyramids P3, P5 for multi-scale detection. Object embedding head replaces class logits with embeddings D equals 256. These contrast with prompt embeddings text visual for open set recognition. Segmentation head borrows YOLACT's prototype masks but shares the backbone, no separate mask branch.
The segmentation trade-off. Mask Dino uses pixel embeddings. YOLOE uses prototype coefficients. Less precise? Maybe. but 23.5 APM on LVIS with 102 FPS on a T4? That's pragmatism over perfection.
Training strategies phased right.
Exactly. Phase 1, text prompts 30 epochs on objects 365 plus gold G. Phase 2, visual prompts 2 epochs, freeze backbone, train SAVPE. Phase 3, prompt-free 1 epoch, train specialized embedding. Total training time for YOLO v8L, 22.5 hours on 8 RTX 4090s. YOLO World 2 needs 3 times longer.
And transfer learning? Freeze the backbone, fine-tune the head on Cocoa for 10 epochs, 80% of YOLO v8 performance with 1% of the data. It's like teaching a polyglot a new dialect in a weekend.
Let's get gritty. Benchmarks LVIS Cocoa iPhone 12. Surprises.
On LVIS, YOLO v8L hits 35.9 AP with text prompts, 5 AP over YOLO World 2S despite smaller size. But the shocker, visual prompts outperform text on rare classes, APR 33.2 versus 29.5. Why? A picture is worth 1,000 words, especially for niche objects.
On Cocoa, full tuning YOLO v8L for 80 epochs beats YOLO v8L by 0.6 AP. Mind you, YOLO wasn't even trained on Cocoa initially. It's like a chef mastering a new cuisine from a single cookbook.
And iPhone 12 latency? 27 FPS for YOLO v8L Core ML optimizations squeeze every drop from the re-parameterized heads. For AR apps, that's real-time magic.
Contrarian corner. Where does YOLO stumble?
The vocabulary gap. If your prompt-free use case needs a category outside the 4,585 built-in terms, you're stuck expanding the dictionary. Plus, multitask learning dense frequent class accuracy. App drops 0.9 versus YOLO World. But for 90% of real-world cases, it's a worthy trade.
And let's not ignore the zero-shot mirage. LVIS numbers are stellar, but in the wild, domain shift bytes, a model trained on generic data might miss defective microchips in a factory. Still fine-tune for 2 hours and you're golden.
Final thoughts. Where's YOLO headed?
3 words, edge device revolution. Imagine drones identifying rare wildlife in real time, or assembly line robots spotting defects without cloud latency. YOLO's efficiency unlocks AI at the far edge. No more begging AWS for more GPUs.
And for researchers, the re-parameterization trick is a blueprint. Apply this to LLM adapters, you'll see me doing backflips.
To our listeners, YOLO isn't just a model, it's a manifesto. Efficiency and adaptability aren't mutually exclusive. Thanks to our experts for this masterclass. Until next time, keep pushing boundaries.